Hey, we have a very familiar integral on the board. It's just the integral of secant x dx. If you need to review, or if you need to just know more about the Weierstrass substitution, I did a video a little ways back. I'll provide a link in the description to give a little more information on where we got all this information over here on the right. So let's get started with this. The whole idea is we're making a substitution that's going to be t equals tan of x over 2, which seems crazy, right? Because our integral is secant, so it doesn't seem to make any sense, but we can actually do the problem this way. In the introduction video, we go over how we got all these other values and how we got our dx value. So there's not too much in this integral. We want to find out, okay, what is secant of x and what is dx? We have our value for dx over here. What about secant x? Well, secant x, as you may know, is just 1 over cosine x, and we have this expression for cosine x over here. So secant x is just going to be the reciprocal of this, which is going to be 1 plus t squared over 1 minus t squared. So doing this substitution, all we need to do is plug back in our secant value, which is 1 plus t squared, 1 minus t squared, and then our dx value, which is going to be 2 over 1 plus t squared dt. And this is pretty nice because we're just going to get this cancellation. So we're actually just integrating 2 over 1 minus t squared dt. And this is actually the 1 over 1 minus t squared is a common integral. We could write this as hyperbolic inverse of t. But I think so we can manipulate it. And we're actually striving for an answer with ln, so I'm going to write this a different way. We're actually going to write this as 2. So this piece can actually be written as half ln 1 plus t over 1 minus t. But the 2 and a half is just going to cancel, and we're going to have ln 1 plus t over 1 minus t. And we could back substitute right now, but I think what I want to do is manipulate what we have inside here a little bit before we continue. So what I want to do is actually just break out this piece and look at it separate. So we're going to have 1 plus t, 1 minus t, and then what we can do is we can multiply by the conjugate in the denominator, and we're left with, let's see, we're going to have 1 minus t squared in the denominator, and then we'll just multiply this out and distribute in the numerator. We're going to have 1 plus 2t plus t squared. And then I can separate this and rearrange it, and we can write 1 plus t squared in the numerator, and then 2t, and then it's the same 1 minus t squared, 1 minus t squared. But you notice this 1 plus t squared over 1 minus t squared, it's just a reciprocal of cosine, the value we found earlier for secant. So this piece right here is secant of x, and then 2t 1 minus t squared, you notice is this value for tangent right here, so tan x. So we have a secant and tan in here, so for our final answer we have ln absolute value secant x plus tan x plus c, and we're done. I got this problem from my quiz, Weierstrass substitution. Most of the integrals in that quiz are integrals where you probably need or would want to use a Weierstrass substitution, but I also mixed in some more common trig integrals just to get more practice. Thanks for watching. Please like and subscribe. Have a great day.